Hello everyone, this is Miss Soma. So today I'm going to be going over the subsets of the real number system. So let's start with the very first set of numbers that we know. So the numbers that we used for counting. So these are numbers 1, 2, 3, 4, and so on. And then, so we call this counting numbers because we use them for counting. And the other name for these numbers are natural numbers. So counting or natural numbers. Then we were introduced with the concept of zero. So zero is not used for counting. So we call them, we put them in a different group. So now we call them whole numbers. All right, now whole numbers also include all the natural or counting numbers. So 0, 1, 2, 3, 4, 5, 6, and so on. They are all whole numbers. But of those numbers, only 0 can't be included in the counting numbers group. Then later on, you were introduced with the concept of negative numbers. So such as -2, -1, -8. So these are the whole numbers and their negatives. And now we don't call them whole numbers because whole numbers are always positive. So we call them now integers. All right, so now the integers group also include whole numbers and the counting numbers. So 0 is an integer, 0 is also a whole number, but not counting. 1, 2, 3, 4, and so on, 5, 6, 7, 10, 12, 1,000, 2,000. They are all counting numbers. They are also whole numbers, and they are also integers. So when you look at this representation over here, so anything that belongs to that bigger circle is also true for that number. All right, so let's see. It's also true for that group. So now we also get the concept of decimal numbers. So such as 0.29, let's see, -2.48. Well, let's do one more. 1.5. Let's do some fractions as well, such as 2/3. We can do some percent. So any numbers that can be represented as a fraction, we now call them rational numbers. So these are the rational numbers. All right. Now, there are also numbers that cannot be expressed in terms of fraction. So we call them, I'll just do another rectangle here that could fit. So we call them the irrational numbers. So these irrational numbers, these are numbers that cannot be written as fractions. So such as square root of 22, pi. So anything that involves pi is also an irrational number. All right, so I want to talk more about the rational numbers. So rational numbers, again, they can always be expressed in terms of fractions. So that would include, so I'm going to do a different section here just for rational numbers because this is the part that's a little bit confusing for some of you. So rational numbers are fraction numbers. So let's say 0.23 for example. Oh no, I'm going to just do 0.3 repeating first. All right, so this can be expressed as 1/3. All right, so now let's see, 0.26 repeating. So how do we express repeating numbers? So all you need to do is you look at up to the what digit is this up to? So that would be, this could be expressed as 26 over 99. So if I would have 0.213 repeating, so that means you would have 213 over 999. Okay, so anything that has a pattern, a repeating pattern, can be expressed as a fraction. So therefore, we classify them as rational numbers. All the numbers that terminates, such as 0.216, these are all rational numbers because you know we can express this as a fraction, which is 216, so tens, hundreds, thousands, 216 over 1,000. So that is a rational number. So again, any number that terminates, so the terminating decimals and the repeating decimals can all be classified as rational numbers. And all the other numbers that cannot be expressed as a fraction, they are considered irrational numbers. So these are all the square root of non-perfect squares and pi. So let's go over it again. So again, let's start with counting numbers. So these are all the, I would say exact numbers. Then followed by whole numbers, which includes 0 and all the rest of counting numbers. And then the integers are the negatives, are all the whole numbers and their negatives. So they're all exact. So all right here, these are all exact numbers here, and which includes the negatives, the 0, and all the positives. And then the rational numbers are those numbers that are not exact, so decimal numbers that has either a repeating pattern or it's a terminating decimal. So you can also look at it this way. Anything that belongs to the bigger circle will be true to that big circle. So that means all the integers, all the whole numbers, all the counting are all rational numbers. Integers are not whole numbers, but whole numbers, since it's inside the integers group, are all integers. Now let's do a few more examples. Okay, so I'm gonna have several numbers here. So, but before we're gonna classify them, let me prepare with our Venn diagram. So the first group is counting, followed by whole, followed by integers, rational, and then we have irrational, and all of these are real numbers. So pretty much all the numbers that you know at this level are considered real numbers. Okay, so imagine this as having a filter. So let's see. I'm thinking of a number -9. So where should I put my -9? All right, so let's think of it as having a filter coming from the outside. All right, real numbers. It can go in here. Can it enter the rational numbers group? Yes. It can still pass through integers, but it cannot pass through the whole numbers group because this is a negative number, so it stops at negative. It stops at integer group. All right, now let's look at 10. Okay, so let's start here. 10 enters. It can be classified as a real number. Try to enter the rational group. It can be written as a fraction. Yes. And then it can be an integer. So remember, integers are all the whole numbers and their negatives. But let's see, can it pass through the whole number group? Yes, it's an exact number, so it's whole. And then, can it pass through the counting group? Yes, it is in fact a counting number, so 10 will go here. All right, let's try another one. So let's say 0. All right, so let's classify 0. Is 0 a real number? Yes. Is 0 rational? Yes. Is 0 an integer? Yes. Is 0 a whole number? Yes. But it's not counting, so it stopped at whole numbers group. Okay, now sometimes, well, let's do another one. So let's see, 2.5 repeating. So 2.5 is a real number. Yes. 2.5 repeating can be written as a fraction. So that's 2, which is equal to 2 and 5/9. So yes, it is a rational number, but is it an integer? No. So it stops at a rational number. Okay, so that's how easy it is. So now we are going to look at irrational numbers. So let's say I'm going to do pi. Anything that involves pi. So say, for example, pi over 2. So even if it looks like a fraction, as long as it involves pi, because pi is non-terminating and non-repeating, so therefore it is an irrational number. And all the square roots of non-perfect squares, such as square root of 2, square root of 12, they are all irrational numbers. So let's do some more practice here. I'd like you to start thinking of a number. So I would like you to think of a number that, I want a number that is counting. It's also whole. It's also an integer. All right, so what would be that number? Okay, so I'm thinking of -5. Let's see. Will -5 be an integer? Yes. So we're looking at -5. All right, so let's look at our circle here. So I'm looking at -5. -5 can enter this group. Is it rational? Yes. Integer? Yes. But then it cannot enter the whole number group because the whole number groups going to the counting, they're all positives here. So this section here are all positive numbers. Integers here will include negatives, but exact number. And then the rational will include the decimals. So it stops at integers. So therefore, it's not whole, it's not counting. So me thinking of a -5 will not satisfy this. So let's see, I'm thinking of a 0. So 0, it is an integer, it is whole, but it's not counting. So that's not the correct number. How about 4? 4 is an integer, it's whole, it's also counting. Therefore, 4 could be an example on this requirement here. Right, let's try another one. I want you to give me a number that is an integer, also rational, but not whole. All right, so think of a number that is an integer, a rational, but not whole. So I'm thinking of, let's say, -2.5. All right. Now, -2.5, if we look at our circle again, so -2.5 can enter here, can enter here, but is it able to enter the integers group? No, it cannot enter here because integers group are all exact numbers. So this wouldn't be the right number. I couldn't have that as an answer. All right, I'm going to think of -9. All right, so now let's look at our circles. Negative 9, it belongs, oh, we even have that as an example here. I have negative 9. So now my negative 9 cannot enter the whole number group, cannot enter the counting group, so it just stops in the integer group. All right, so it's an integer, and since it's inside the rational, it was able to pass through the rational group, well, it is also rational, and cannot pass through the whole number group. So therefore, this match the qualification that I'm asking. So a negative 9 could be an answer, a negative 8 could be an answer, a negative 12 could be an answer, but 4 is not an answer because 4 is allowed to get into the whole number group down to the counting groups. But in my qualification, I only want something that is not whole. All right, so let's do one more. I'm thinking of a number that is an integer, but not counting. All right. Where is that? All right. So I want a number that is not counting. All right. So let's think of negative 2.5. Is negative 2.5 an integer? So let's check our circles. All right. It can pass through the rational group. All right, can it get to the integers group? No, because integers, they may include some negative numbers, but they have to be exact. Negative 2.5 is not exact. That's not an integer. So then that couldn't be right. All right, so let me see a negative 11, for example. Okay, let's check the circle. Negative 11 can go through here. It can go through here. Can it be whole? No. So since it cannot be whole, it cannot get through the counting group either. So let's see. So is negative 11 an integer? Yes. Is this not counting? Yes. So that could be an answer. A negative 9 could be an answer too. A negative 22 could be an answer. So any of those numbers, but I cannot have positive 10. 10 is an integer, but it's also counting, so therefore I cannot use this as an answer. All right, so in case you still have more questions, please shoot me an email and I will respond to you as soon as possible. After watching this video, I would like you to proceed with the real numbers activity that I'm posting on, I believe, for Wednesday's lesson. All right, till next time. Bye-bye.